So you're going to get your quiz back. On Friday, we have our equivalency test. That's 100 points. On Friday, we also have our expressions test, which is 100 points. So that's dealing with those variables where we order of operations, one step at a time. When we take the number, put it in place of the letter, do one step at a time, where we write out an expression which is a math problem with letters and numbers. Also, our vocabulary is going to be on there. We'll go over that vocabulary and talk about it again on Thursday. Today, we're adding some more vocabulary to that, talking about some properties of numbers. So what a property is it's a statement that is true for every number. So you'll notice I underlined every. So that means it's true for positive numbers, it's true for negative numbers, it's true for fractions, it's true for decimals, it's true for everything. Alright, today when we talk about these properties, we have 4 properties we're going to go over. One is the commutative property, and it says of addition and multiplication. Then we have the associative property of addition and of multiplication. Then we have an identity of addition, and we have an identity of multiplication. Everything we're doing today is adding and multiplying. The reason behind that, does order matter when you add numbers up? No. Does order matter when you multiply numbers together? Does order matter for subtraction, though? Yes. Does order matter for division? Yes. So these properties would not work for those. So when we're writing down our properties, we have to be specific. We have to write commutative property of addition or of multiplication, and we'll look at that today. I taught 9th grade Algebra 1 and Algebra 1A for 5 years before starting to teach 6th grade. First 9 weeks of Algebra 1 in the 9th grade, we did these properties. We did the commutative of addition, the commutative of multiplication. We did these identities. Now, of course, by 9th grade, we've added some more on there as well. All right? But I promise you, this is in the Algebra 1, your 9th grade course of study. Your teacher has to teach you this. So if you'll learn it in the 6th grade, you're like halfway there come 9th grade. All right? When we're talking about the commutative property of addition or of multiplication, the word commutative, there's a word that we use every day in English. It's the word commute. Has anyone ever heard the word commute before? Okay, here we go. English lesson. Commute. Here's an example. Your parents commute to work each day. You commute to school each day. After school, you might commute home, or you might commute to practice. All right. So what am I using the word commute? What could I substitute in there? Peyton? Come. Yeah, you come, you go. You go to school every day. You go to practice some days. All right. Your parents go to work. All right. The word commute means you are going somewhere. You are changing location. We are going from being at our house to being at the school. So you're changing location. And that's going to matter here because when we're talking about the commutative property, it's going to allow numbers to change location. It's going to allow the numbers to change location. So here's the cool thing about what we're doing today. You're not going to have to do math. You're not going to have to do math with this. All right? All you're going to have to do is be able to tell me, this is commuting, this is associative, this is identity. So if the numbers are changing location, what is it? The commutative property. So I'm going to give you an example that you would have to identify. So on the test, for example, if I had a problem that said 7 plus 9 equals 9 plus 7, your job would be to say, what property is that? Okay? So if you'll notice, 7 was at the front. Where did it move to? The back. 9 was at the back. It moved to the front. That's the commutative property. Your job would not be to do math. Your job would just be to say, that's the commutative property because my numbers moved location. You're not working anything out. It's just kind of like a matching game. All right? That's exactly what it is. It's a matching game. Okay, Frank?
Like borrowing, you have to move the
So the difference with borrowing is you're actually taking something away from something else. Here, my 9 and 7, they're not taking anything away from each other. They're just going to change locations. They're just like trading. So it's kind of like trading places. Okay? I'm sure you've done that sometimes if you're in line and you have a friend, you're like, hey, trade places with me. And if they're nice, sometimes they will if they're in front of you, okay? All right? That's basically what's happening here. Your numbers are trading places. Now, here's the thing, guys. When you trade places, is it fair if you go from the end of the line all the way up to the front of the line? No, everyone around you is going to be real mad. You might have a friend, but that friend and you, everyone's fixing to not like y'all very much, okay? So when we're talking about these numbers, they can trade places, but they can only trade places with the number next to them. Because if you just change places with the person in front of you, is anyone else around you going to get mad? No, their place hasn't changed, okay? So when numbers are changing places, when they're commuting, you can only do the numbers that are right next to each other. So here's another example. Let's say I have 2 times 3 times 5. Okay, I want to change the places with the 5. 5 doesn't want to be at the back anymore. Can 5 jump all the way up to where the 2 is? No, the only number 5 can change with is the 3. So that would change. 2 still gets to be in the front, but his friend 3 is going to let him trade places. You'll see how 2 can't get mad. 2 is still in the front, but that 5 and 3 were able to change places with each other. Okay? If it works for every single number, I can actually do this with letters. All right? I'm not going to do math with letters. I'm just going to move them around like I did the numbers. So, for example, if I have A times B times C, okay? Again, I'm not actually multiplying these. I'm just going to move them around. So let's say B wanted to move. What can B switch places with? Peyton? A. Can B only trade with A?
No, it's
B could also change with C. All right, the problem is going to tell you which one, but do we understand it has to be one or the other? Okay, so I'm going to change it with A, so I'm going to change that to B times A times C. Okay? So the commutative property lets them move just the numbers. Okay?
okay. So like, when C wanted to be in front of A, so
Okay, so if C wanted to be in front of A, it would have to get B to switch places with it, right? So it'd be like, hey, let me trade places with you. Then it would also have to get A to change places with it. So it would actually take 2 steps. All right, but here's the thing. In the 6th grade, we're just going to do one thing at a time. Okay, so I just need you to tell me these 2 numbers are moving. That's commutative. Okay? Yes, Peyton?
I understand that B always going to be in the front, but what if C just goes in front of A?
So C can't jump in front of A because then B might get mad. All right? But I can change places with C and B. Then on the next step, I can move C with the A. But you can't jump. They can only move next to each other. All right? And the reasoning behind that, guys, is this is the property of addition. So I can only really change around the addition sign. Or multiplication. I can only change around the multiplication symbol. Right now, do A and C have one multiplication symbol in between them? No, they have 2. So I have to change my A and B and C that have 1. Or I have to change my A and B that have a sign in between them. Since A and C don't change a sign, we can't change them. Okay? So they have to be neighbors to trade. Yes?
First, what would it be with parentheses?
We're fixing to get to that.
And second,
Okay. All right. Also, side note, guys, you'll have time to get all of your homework done in class, so don't be skipping ahead. Okay. All right. So let's talk about the associative property. So commute means you're changing location. The associative property of addition and multiplication has to do with associates or associate. So has anyone ever heard, or does anyone know what the word associate or associate means? Peyton?
does it mean like that you stay one place?
RJ?
Like
Yeah, it's who you hang out with, who you talk to, who you hang out with, all right? So your associates are the people that you are around. So right now, we are all associates in this math class because we're all studying together. Next period, are you going to have the exact same associates? No. All right, in fact, you might have some associates that you have at school. You might have some certain friends that you hang out with here. So like when you go home and in your neighborhood, you might have different associates. All right? So associates are the people that you're around. All right, and again, you might be around them for different reasons. Like we're associates because we're all in math class together. I also have associates that I work with. Those are other teachers that I work with. All right? So associates are groups of people. Y'all good with that? Associates are groups of people. So in math, what would form groups of numbers? What would make numbers be in groups? What symbols? Raise your hand if you can tell me. What symbols would make numbers go together? Noah?
Addition.
So addition, I'm doing something. So I'm not doing anything to the numbers. I just need to say, hey, these are together. What symbols would let me put numbers together? I don't want to do anything to them. I just want to group them together. What symbols would make groups, would group things together? Mary Webb? I'm not wanting to do anything to the numbers. I want to group them. I don't want to do any math. I don't want to add, subtract, multiply, or divide. I want to group them. Jakaria?
I forgot what it's called. Abbreviation. Not abbreviation. What's it called?
You're making the right shape. Peyton?
Is it parentheses?
It's parentheses. Those are the things that Jakaria was making. Those things that you put around the numbers. So parentheses make my numbers in groups, okay? So what the associative property does is it allows those groups to change by allowing grouping symbols to move. So for the commutative, we were letting the numbers move. Now we're letting the grouping symbols move. Grouping symbols. And we'll even put parentheses around them to help us remember that. Or not around them, but next to it. So grouping symbols, which are those parentheses. All right, the associative property allows grouping symbols to move. An example of this. All right, an example of my grouping symbols moving would be like if I have 9 plus the 3 plus 4. So right now, 9 is by itself. 3 and 4 are grouped together. We could move those parentheses down. So let's say 3 and 4 right now. Maybe 3 and 4 go to school together. So they're stuck together. But then when 3 goes home, 4 is no longer at school, but maybe 9 is the neighbor. So now my group has changed. Now 9 and 3 are together, but 4 is not in their neighborhood or something. All right? Or maybe here 3 and 4 are friends. They have a disagreement. 3 is like, I don't want to be friends with you anymore, and it becomes friends with 9. Okay? But either way, the group, the people, the numbers that 3 is hanging out with have changed. All right?
I found my second. When I was looking at the homework time, number 12.
Okay, well, let's wait until we get there, okay? We've only done 2 definitions. Yes, Peyton? Yep, we can use letters as well. So I'm going to go ahead and do like a multiplication example and a letter example at one time, okay? Remember, those letters are called? Variables. Variables, okay. So here's a variable example. Let's say I have A times B. And then we still have a times C out to the side. And that's going to equal A times B times C. All that happened is my parentheses moved down. A and B aren't together now. B and C are together. Did my letters actually move? A, B, C, A, B, C. My letters didn't move, just the parentheses. Someone asked the other class, I thought this was a really good question. They asked, what if there are 4 involved? So like I think we did 8 plus 7 plus 11 plus 3. So if I have like 7 and 11 are together, my next problem could make 8 and 7 together. So I could say 8 plus 7 plus 11 plus 3. Did any of my numbers move? No, my parentheses just moved down. They moved up or down. Okay. Questions about the associative. Associative is those parentheses are moving. Yes.
Can letters and numbers be in a
Mm-hmm. You could. So that's a good question too. So I could have something like, and I'll do some multiplication again. I could have 8 times x times 4. And let's say right now 8 and x are together. I could move that to say 8 times x times 4. You see, I'm not actually doing any math at all. And guys, your job would literally be to look at that and say, oh, that's the associative property. Oh, that's the associative property. Oh, that's the commutative property. Your job is just to match it. Say what it is. Okay? Peyton?
There's 3 parts to the bottom one. I see it right there.
Hmm?
You put the first one, which is 8 plus 7 parentheses, and then 11 plus 3.
So, okay, so you're not going to do that. There's one set of parentheses here, right, Peyton? So I can only move it down to keep one thing.
I'm talking about like, there could be like 3 ways of doing it.
Yeah, so, or we could have moved it to the, yes, or we could have moved it to spell it in 3. Sorry, Peyton, I understand now. All right, let's talk about the identity of addition. What is an identity? What is an identity like in regular, the world? RJ?
Like a person.
Like a person. It's like who you are. All right? So I have Gabriella and I have Gabby. They're both Gabriellas, basically, okay? Does that mean they're the same person because they have the same name? No. All right? They're very, very different, okay? So when we're talking about numbers, it's the same thing. They're all numbers, but they're very, very different. So when we're talking about the identity of addition, it's something that's not going to change it. So, for example, if I have the number 2, what can I add to 2 that's not going to change it? What could I add to 2 that won't change the 2? 2 plus what? Would not change it. Haley? 0. So the identity of addition is adding 0. Keegan. All right, adding 0. Because just like I said, example, 2 plus 0 equals 2. Did that number change?
No.
Does adding 0 to any number change it? No. So if I wrote this with a variable, let's say x plus 0. X can be any number. When I add 0 to it, is it going to change? No, it's still going to be x. It looks like we did math to x, but I really didn't. I just know that adding 0 means nothing. I really just took away that 0. Do y'all see how I didn't do math with the letter? I just took the 0 away because it doesn't do anything? Okay. What about identity of multiplication? What could I multiply by to where it would not change the number? What could I multiply? Let's think about 2 again. What could I multiply 2 by to where it wouldn't change the number? Peyton? 1. So the identity of multiplication would be multiplying by 1. So an example of that, we could do the same thing. 2 times 1 equals 2. So if I had n just stands for a number. If I have a number times 1, is it going to change at all? No, so it would still be n. Can I do that with any other number? No. You can't actually add or multiply by a number, but if it's adding 0, that's not doing anything. Take the 0 off. Multiplying by 1, that's not doing anything. Take the 1 off. All right? So we're going to look at these next set of examples. This is going to be kind of what is like on your test. It says identify the property. So on number 1, what's happening here on number 1? Easton? How did you know it was the associative property? Yeah, so for 1, this problem has parentheses. So already I'm thinking, hey, something's up with those parentheses symbols. And if I look, 35, 17, 43, 35, 17, 43, my numbers are in the same place, but my parentheses have changed. So I would just write down, hey, this is the associative property. So what operation is happening here? Of addition. So I just write down of addition. So here's the good news for my anti-math folks. You're not actually doing math here. You're just matching what it is. You're just matching it. we'll look at that in a minute, okay? I have something that we can put that together with. You just kind of hold them up. All right, number 2. What property do you think is happening on number 2? What property is happening on number 2? Peyton?
Identity of addition.
Identity of addition. We're adding 0. Did it change it? No. So this is the identity of addition. All right, number 3. Number 3, what operation is happening here on number 3? Number 3. 20 times y times 6 is the same as 20 times 6 times y. Very well. It would be, because 20 was at the front, then I had y, then I had 6. Then y moved to the back, and 6 moved to the middle. So that y and 6 changed places. Do y'all see that? So this would be the commutative, what operation?
Commutative property of addition. Of multiplication.
Commutative property of multiplication. All right, what about on number 4? N times 1 equals n. Brain Bulgar? Identity of multiplication. In fact, that's the exact example I wrote there. I didn't realize that. Identity of multiplication. Okay. All right, for the next set of examples, what we're going to be doing here is we're going to be determining, hey, are these equal? And if they are, we need to say the property. And if they're not, we're going to explain why. All right, so it says determine whether two expressions are equivalent. That word is just a fancy way of saying equal. If they are, we're going to name the property. If not, we're going to explain. So it's kind of like what we were doing here, but sometimes they're not going to be equal, and we'll have to word it a little differently. So on number 1, 64 plus 0 and 64. Are those two things equal to each other? Are those two things equal? Let me see a hand so we can get a reason. Noah?
Yeah.
Yes. What property makes those equal? From the 4 properties that we listed up above, what property says 64 plus 0 equals 64? Noah?
Associative property of addition.
So associative would be those parentheses moving. There are no parentheses here, so that can't be it. RJ?
Identity of addition.
This is the identity of addition. Did 64 change? No, 64 kept its identity. So this would be the identity of addition. All right, number 2. 8 divided by 2 and 2 divided by 8. Are these equal to each other? Keegan? No. Why not?
Because if 8 divided by 2, you can't do it.
8 divided by 2?
Oh yeah, that's 4.
8 divided by 2 is 4. And 2 divided by 8?
Oh yeah, 4.
2 divided by 8 would be a decimal.
Yeah.
All right, so you're right. These are not equal. What property are they trying to use here?
Commutative property.
They're trying to use the commutative property, but is there a commutative property of division?
No.
No. So I could say no commutative does not work on division. So we're really kind of still saying the property. We're just saying, hey, it doesn't work on division. Okay? So each time we're saying yes or no. We're saying the property, and either the property did work because it was of addition or of multiplication, or it didn't work because it wasn't. All right, so on number 3, what is this equivalent? Is this equivalent on number 3? Are these the same? RJ? Yes? What property says they're the same? Commutative property of addition. So can we just say on number 2 the commutative property doesn't work? No, the commutative property does work, just not on division. So make sure we're careful there. Commutative property. All right, number 4. For number 4, are these equal to each other? Are these equivalent? What do you think, Mason? 8 plus 27 plus 52, does that equal 8 plus 27 plus 52? No. So if I add these, okay, so let's think about this. If I add 8 and 27 together, that's going to give me 35. And then 35 plus 52 would give me 83. Right here, 27 plus 52 would give me 79. Did I do my math wrong? 79, and 79 plus 8 is 87. So let me check my math. I did something wrong. 8 plus 27 is how much? 35? Ah, there's where it is. 35 plus 52 is 87. And 87. So they're both 87. So are those equal? Yes. And if you're not sure, can you add them up to check? Yeah, we just did it. Yes, those are equal. Why? So if I know they're equal, I know I need to look back at my properties. Look back at my properties. What property says these are going to be equal? So what properties am I using? If it has parentheses, it should be kind of obvious. What property does the parentheses? Morgan? The associative property. And is there an associative property to go with addition? Yeah, so I knew this was going to be true. So this would be the associative. Please do not abbreviate that word. Property, or any of your words for that matter. Property of addition. All right. Number 5, 0 plus 32 and 0. Are these equal? Gabriella? No. No. What property were they trying to use? They were trying to use the identity of addition. But what should the identity of addition say?
32.
Yeah, identity says 0 plus 32 should equal 32. Does that tell me why that didn't work? Yeah, they did the identity wrong. So I said, no, the identity actually says it should be 0 plus 32 and 32. All right, number 6. Are these equal? Are these equal? Kelsey, what do you think? No, why? It's subtraction. Have we seen anything with subtraction? No. So what property are they trying to use subtraction with? What property is it that they're trying to use? Peyton? Associative. Guys, on that first one where it had division, it should have been obvious. That's division. None of our stuff works for division. Here, this is subtraction. I should know. That's going to be no. And we're going to say associative does not work for subtraction. Okay? Questions about that? All right, I want you to flip it over. Guys, this is what you're doing on your homework. All right, my advanced students are doing the entire back. This bottom part is something we did not do in our notes today. I want for you guys to mark that out. Okay, so we're going to eliminate those. I want you just practicing your properties. Remember, it's either yes or no. If it's adding or subtracting, it's probably, if it's adding or multiplying, it's probably yes. Okay, and then pick your property. All right, guys, I know I said that we were going to work some of them together, but we just did 6 of them together. I want you to try doing these 12 on your own. Since we took off the bottom for the regular classes, I want you to try doing them on your own. Okay?